formula for volume's about the y-axis. So, for example, you're rotating, you might have this curve like this. Doesn't matter, anything. And you rotate that about the y-axis. For example, that would end up like this. The way you might want to draw it, let's say you're given that there, do the mirror image in the y-axis and then draw that thing around there. So this is an example of something being rotated in the y-axis between the values of B and A. So instead of it being, because you're rotating about the y-axis, it's dy, but the formula is not y squared dy, it's x squared dy. So this is the formula for rotation about the y-axis. Volume equals pi, B on A from B, pi, integral from B on A, x squared dy. Again, just follow the formula. Make sure you substitute in that x squared value. You're rotating about the y-axis, so you need y values for the substitution. How do you know that? It's dy. It's rotated about the y-axis. It's integrated with respect to the y-axis. First question. Wait till tomorrow.
No, if it's over 40 degrees, I'm not coming to college. Isn't it illegal? No, that rate is like 43 or something. Oh, that's
First example. Find the volume of the spherical cap formed when the curve x squared plus y squared equals 4. What's that? Yeah, is rotated about the y-axis from y equals 1 to y equals 2. Now, it has a radius of 2. Let's just do a sketch. It's rotated about the y-axis, so let's write out the formula before we start. What's the formula for rotation about the y-axis? Pi, B on A. It's definitely dy because you're rotating about, so it's x squared dy. Remember, you've got the formula sheet. So let's just sketch what it looks like. It's a circle with radius 2, so it looks like this. But the bit that's being rotated is from y equals 1 to y equals 2. So only this bit is rotated. Oh, I suppose you could even say that too. And then it rotates around the y-axis. So here's one side, draw the same thing on the other. You're going to end up with this spherical cap. Sorry, wait. That's what you're going to end up with, that. Okay? Like the top of the sphere.
So do we make x squared the subject?
Yes, so you just make x squared the subject. So we've got x squared plus y squared is 4. So that's why I'm saying your formula, just follow it. If you follow that formula and substitute into it the way you're supposed to, you won't have a problem. It's 4 minus y squared. So it's pi. You're substituting in y values. Guys, if you're integrating with respect to y, that your function is in terms of y. See, notice you've got 4 minus y squared. Sorry, that 4 stuck to the minus. So we got 4 minus y squared dy, which is pi. What do I do? 4y minus on 3. Substituting in the values of 2 and 1, which is pi minus 8 on 3 minus 4 minus a third, and then just work it out. 8 minus 2 2/3. Is it 5 and a third or something? 5 and a third minus 3 2/3, which is 5 minus 3, that's 2, Is it 1 2/3? 5 pi on 3 units cubed. Okay. Oh, you can just go improper. It's easier. 16 minus 11 is 5. Improper is better instead of what I just did. I did it like a year 7 would do it. 5 minus 3 is 2. 1/3 minus 2/3 is minus 1/3, and 2 minus 1/3. Of the solid formed when the line y equals x plus 2 is rotated about the y-axis from y equals -2 to +2. Oh. You can write the formula out first. I like to do that. Rotation about the y-axis. So make sure you got the correct formula. Pi. Yeah. I still would. It's good practice. X squared dy. So that's your formula. And now you just go about finding x squared. Let's do a quick sketch. Make sure everything's right. Y equals x plus 2. Yep, it's a straight line.
No, that goes through 2.
Yep, and it goes through -2. It looks like this.
And then don't you square both sides and you get x squared? So y squared equals x squared.
Guys, that's the line y equals x plus 2. Between which values are you substituting? So I've got to come further down. You're substituting between -2 and +2. So this is the bit that gets rotated about the y-axis. So to do your drawing, reflected in the y-axis, it'll be a cone. Reflected in the y-axis, draw that, so you've got your line there, y equals x. So this is y equals x plus 2. Do the reflection in the y-axis and you can do shading. That's what it looks like.
Can we make x squared so it's y squared equals
Yeah.
x squared plus 4?
So we've got y equals x plus 2. So what is x as the subject? I need x to be the subject. Y minus 2. Now you can do it a few different ways. X squared is?
Y squared minus 4.
Well, you can do y minus 2 all squared. It's not y squared minus 4. It's y minus 2 all squared. Look, you could expand it if you want, but I wouldn't. I wouldn't expand it because you're going to end up with 3 substitutions. You know, this way you actually only end up with the 1 substitution because you're putting in a value for the y. You're just going to do something cubed over 3. So please do not expand it. You're just going to make it harder for yourself. So let's come back here and substitute in our values. And what have we got?
2
And -2. X squared is y minus 2 squared dy. It's looking good because this function is in terms of y and we're integrating with respect to y and we're substituting in y values. Please check all these things. Keep the pi out the front and you've got y minus 2 cubed over 3 times the coefficient of y, which is 1. Notice you only are doing 1 substitution. If you expanded that, you'd have y squared minus 4y plus 4. You want to expand, substitute in 6 numbers, because you will be substituting in 6 numbers if you expand it. So I'm hoping people haven't gone ahead and expanded it. They're just making it easier to make a mistake if they've done that.
It's 0 minus.
So, yes, so you get 0 for the first substitution, so it's quite easy if you do it like this. And then we get -4 cubed, which is 64. But look, we've got a negative and a negative, so it's positive. It's 64 pi on 3
Can you
units cubed.
You can simplify it.
64 on 3, no. Okay. All right, and that's that. I was going to do another one, but I don't think so.
Can you do an afternoon lesson now? Like right now?
All right, we'll continue others tomorrow. You know what I just want you to do is to finish
3.8.
3.